Welcome back to Survey of Mathematics. I'm Jeremy Pletcher, the author of the Survey of Mathematics. Today we're going to be looking at types of statements in comparison between two types of truth tables. So when a statement creates a truth table where all the final outcomes are true, that is what is called a tautology. So in the creation of our truth table, if in the process our final column is all truths, it's called a tautology. On the other side, if our final outcome are all false, that is what is referred to as a self-contradiction. So when we look at our final outcomes of truth tables, if they're all true, a tautology. If they're all false, a self-contradiction. So let's take a look at this particular table and see if it is one of those two types. So first thing I need to do is I need to create a column for P or Q. So right here I'll start out with P or Q. Either one being true is going to give me a true outcome to that particular column. So this will be true, this will be true, this will be true, and that final line there is going to be false. Now I look at my next statement. It is the negation of P and the negation of Q. Well, I am going to create a column for the negation of P. So I'm going to take this first column, the P column, and change them to the opposite. So that's going to make it false, false, true, true. And then I'll make another column for the negation of Q, where I look at the second column, and I'm going to change those to the opposite. So it will become false, true, false, true. Then I can put those two statements together. So the negation of P and the negation of Q. So I look at these two columns here. In order for it to be true, both statements have to be true. The only time that happens is in that final row there. So the first three rows are false and the last row is true. I'm going to combine the two statements. The first statement that I need to look at is the P or Q column. I'll call that column 1. And then this column right here, which I'll call column 2, which is the negation of P and the negation of Q. So taking those two together, combined with an or, if either statement is true, then the outcome is true. So if I look at column 1, the top 3 lines are true, so I can put true on the top 3 lines of this column. The last one on column number 1 is false. So I need to look to see, is the second statement true? And sure enough it is. And so our final outcome of this truth table is all true, which means this is a tautology. All of the final outcome is true. Let's try this table. We have if P, then Q. So I need to create that column. So here, true and true, my final outcome's true. Here, I emptied the dishwasher but did not give ice cream, if I go back to an analogy I used yesterday. So I emptied the dishwasher, they did not give me ice cream, therefore they told a lie. Here, I did not empty the dishwasher but they gave me ice cream, but that's okay. And over here, I did not empty the dishwasher, they did not give me ice cream, and so they told the truth there. So for that column, it's true, false, true, true. Again, the only time an if-then statement is going to be false is when the first statement is true and the then statement is false. Then I look at this next piece here. I've got P or Q, so I need to create that column. If either one of the statements is true, then the final outcome is true for that column. So here I look, P is true for the second row. In the third row it is not, but Q is, so that is also going to be true. And in the last column they're both false, so my last row there is going to be false for that column. And now I'm going to combine these two statements. Let's call this statement 1 and statement 2. So I have 1 and 2. In order for it to be true, both statements have to be true. I see that in the first row and in the third row, but the other 2 rows I do not. I have opposite values, and therefore it is going to be false for those 2. So is this a tautology? No, because not all final outcomes are true. Is this a self-contradiction? No, because the final outcomes are not all false either. So this would be neither a tautology or a self-contradiction. If we were to compare two truth tables, they could be what we call logically equivalent. What that means is their final outcomes are exactly the same, in the same order. Whatever was true on the first is true on the second. Whatever was false on the first is false on the second. As an example, these two statements would be logically equivalent. So I have if P then Q, the final outcome of that is true, false, true, true. And then I have if not Q, then not P. When I work that out, I get an outcome of true, false, true, true. Notice that the two columns in red have the exact same truth values in the exact same order. Therefore, this would be considered a tautology. Negations of compound statements are not always easy to figure out. You would think, for instance, that the negation of P would simply be the negation of P. So for simple statements, that is true. But for compound statements, the final outcomes have to be exactly the opposite in each case. So if I have a truth table that is true, true, false, false, then the negation of that particular table would have to be false, false, true, true. Exactly the opposite outcomes in my final column. You may think, for instance, that the negation of P and Q would be the negation of P and the negation of Q put together. But let's work out those two truth tables to see if they really are negations of each other. So here I have P, Q, here's P and Q. It would come out true, false, false, false. Then if I work out the negation of P and the negation of Q, I end up getting false, 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 true. Notice that that first line, I have true and then a false, so those are opposites. I see that same thing in the last row where I have a false and then over here a true, but these middle two rows are the same. A false here, a false here. So these are not negational statements. What do we need to do in order to negate the statement? Well, this final column here would have to be false, true, 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 in order for it to be a negated statement. Now, if we take a look at this example where we have P and Q, and the negation of P or the negation of Q, we see that we have opposite final outcomes. Here I have for the P and Q, the true, false, false, false that we saw in the previous slide. But over here, the negation of P or the negation of Q, I have false, true, true, true. So these are exactly the opposite. What was true on my first column here is false on the second. What was false on the first is true on the second. So we now have a negation of our original statement. So let's determine if these two statements are logically equivalent, they're negations, or they're neither. Again, in order to be logically equivalent, they have to be exactly the same in the same order. In order to be negations, they have to be exactly opposite in that order. And if they're neither, then that means there's going to be some that are the same and some that are opposite. So here we have, if not Q, then P. Well, I don't have a negation of Q column, so I'm going to go ahead and create that. And that's going to become false, true, false, true. Then I need to look at, if not Q, then P. What is the truth value of that particular statement? If the original statement is false, there's no way the other person can lie. If the person never emptied the dishwasher, it does not matter whether they get the ice cream or not. There's no way the promise cannot be kept. So, if I have the negation of Q, then P. If my negation of Q is false, then I can put down true. Now in the second row, they emptied the dishwasher, so to speak. So the question is, did I give them ice cream? Yes, I did, so I told the truth there. Here they did not empty the dishwasher, therefore I cannot lie. Here they emptied the dishwasher. Did I give them ice cream? No, I did not. Therefore I lied. So that's a false. Now I'm going to look at my second statement. So I've got my first statement drawn out. It's a true, 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 false. In order for it to be logically equivalent, my next statement would have to be true, 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 false. If it were a negation, it would have to be false, 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 true. So let's take a look at the second statement. I do have the negation of P, so I need to make that column. And that column is going to be false, false, true, true. Now I need to make a column for the if the negation of P, then Q. So here I look at if P, the negation of P is false, then there's no way that the person can lie. The dishwasher was never emptied, so there's no way to break the promise. So that's true as well as the second row. In the third row, I do have a true statement. So they emptied the dishwasher, so I need to see if they got ice cream. So I look at the Q column, and in this case they got the ice cream, so that's true. Down here they emptied the dishwasher, however they did not get the ice cream, so that is a lie. So we can see that these two truth tables have exactly the same outcome. They are logically equivalent in their nature. All right, let's try this truth table. I'm going to first start out with P and Q. So in order for the P and Q column to be true, both statements have to be true. I see that only in the first row. The other three rows are all going to be false. Now I look at my second statement. Well, in my second statement I have a negation of Q. I don't have a column for that, so I'm going to go ahead and create it. I'm also going to create a negation of P column. And so we end up getting the negation of P being false, false, true, true, and the negation of Q being false, true, false, true. Now I'm going to put those two statements together with an OR. So if either statement is true, then my final outcome is true. In the first row, they're both false. In the other three rows, I have at least one of them being true. Therefore, it's going to be false, true, true, true. Now, if you compare these two columns that are in red, you can see that they are exactly the opposite. Here I have true, false, 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 whereas here I have false, true, true, true. Therefore, these two statements are negational statements. If we go with this truth table, still trying to determine whether it's logically equivalent, a negation, or neither. I have a P and a Q. I first of all need to make a P or Q column. Again, since it's an OR, either statement being true is going to give me a true value. So I have all trues except for that last row where it is going to be false. Then I need to negate that particular statement. So I'm just going to take that column and I'm going to change it to the opposite truth values. So it's going to end up becoming false, 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 true. Now I need to work with my second statement. I have the negation of Q that I don't have a column for, so I'm going to go ahead and create that column. That gives me false, true, false, true. And now I need the if-then statement. So if P, then the negation of Q. Here they emptied the dishwasher. Did I give them ice cream? No, therefore I lied. Here they emptied the dishwasher. I gave them ice cream, so I told the truth. Here they did not empty the dishwasher. There's no way I can lie, so I told the truth. Here they did not empty the dishwasher. Again, no way I can lie, so I told them the truth. So if we look at these two columns that are in red, you can see that they are not exactly the same, and they're not exactly opposite. This first row, they're the same, but in the second row, they're opposite. I didn't even have to look at the others. I know based off of those top two rows that they are not logically equivalent, they are not negations, therefore they are neither. All right, if we go with P and Q, I'm going to make that column. In order for it to be true, both statements have to be true. We only see that in the top row. Then I look at this second statement here. I need to combine the negation of P, which I don't have, so I'm going to create that column, making it false, false, true, true. I also need to combine it with the negation of Q. Well, I don't have a column for that, so I'm going to go ahead and create that. That's going to be false, true, false, true. And now I'm going to combine those two statements with an OR. So if either one of the statements is true, then the final outcome is true for that column. So I see that in the last three rows, but the first row is false. So I end up getting false, true, true, true for that column. Now I'm going to combine those two statements. So if I take a look at this column right here, let's call this column 1, and I take this column here, column 2. I'm going to combine those two columns with an and. So they both have to be true in order for my final outcome to be true. And if you look here, I don't have any of those cases, so they're all false. So what kind of statement is this? This is what we call a self-contradiction. All right, what about the negation of P, or if P then Q? So I've got a P and a Q column. I need to create this negation of P column, so that's going to be exactly the opposite of my first column there, so false, false, true, true. Then I need to make a column for if P then Q. So here they emptied the dishwasher, they got ice cream, I told the truth. In the second row they emptied the dishwasher, they did not get ice cream, therefore I lied. In the last two rows they never emptied the dishwasher, so I'm not obligated either way. There's no way I can lie in those situations. And now I'm going to combine those two statements with an or. So if either statement is true, then my outcome is going to be true. I see that in all three of the four cases. The only case where it didn't happen, where they were both false, is that second row where it is false, false. So I have true, false, true, true. Is this a tautology? No, because of this one line right here. Is this a self-contradiction? No, because the other three statements are true. Therefore, it is neither.